This is 10 chapters, and chapter 4 got part 1 and part 2. Okay, so for this course, your lecture is only 1 hour. Okay, it's only 1 hour today. Okay, 5 to 6. And then your practical 2 hours. Okay, each of you will have practical with me 2 hours. And then tutorial 1 hour. Okay, tutorial 1 hour. So it's a 3 credit subject. So for those don't know me yet, okay, introduce myself. So this is me. Okay, call me Miss Chais or Miss Christy. So my room is below FOCS office A110. Okay, same floor with the exam department. Okay, this is my email address. So if you already joined the Google Classroom, you can get my email also. Okay, and my appointment page. Okay, this one is in your lecture 1 slide, sir. You can click there. That's my appointment page that you can make appointment. Okay, this consultation hour is not correct. You follow the one that in your lecture chapter 1 slides. Okay, so you have to make appointments before you come for my consultation hours. Okay, very bottom must make appointment. Okay, the mic. No okay. No okay. No okay. Miss don't use mic, you can hear. You cannot hear. No, Miss not feeling well, cannot don't use mics. Please make appointment 2 days in advance when you want to come to see me. Can be offline or online. If anything you need fast response, you ask during the class. Okay, during the practical class or your tutorial class. Okay, so only you need extra helper for your practical, your assignment. Then you make consultation hours. Okay. So offline, you can come to my room. Okay, during that time. Okay, if online, then you create the Google Meet link. Okay, can consult online as well. Okay, so what will be learned in this course? Okay, graphic programming. So we will learn all the graphic techniques. Okay, techniques such as how to create the graphics using code, the primitive, the shape. Okay, then after this, all the colors, the properties. And then how to play around with your camera, and then your texture, lighting, okay, shadows. These are graphic techniques that you're going to learn, okay, throughout the semester. And we will use a mathematic concept. Cannot run away with maths. So all software engineering students good in maths, right? You got maths. Okay, so use all the trigo, okay, trigonometry, your senior course, I still remember, and matrices. Okay, you will see a lot of formulas here. We will apply it and use it in our code, okay, in order to produce graphics. So at the end of the semester, this is your assignment, able to implement or to create or produce a 3D interactive graphics applications. Okay, assignment. So we will go to in detail your assignment, how you're going to create this 3D interactive graphic application at the end of the semester. Okay, and we will understand how the graphic API means application programming interface. Okay, your hardware, how your hardware work. Okay. Okay, to communicate with your graphic card. Okay, so this course, you need to have a good graphic card, your machine. okay or not? Later you're going to suffer. If your graphic card is not good, okay, you press the play button, then you wait 10 minutes, your graphic cannot come out. Then you will be suffering when you do your assignment. Okay, it's time to upgrade your RAM, okay, your graphic card, and your spec of your machine. Oh, you are year 2 already. Okay? So we'll understand how your graphic API and the graphic hardware work together. Your graphic card to communicate with your program. Then at the end you can show the graphics on your screen. Okay, on your computer you can see the graphics. So what is not covered in this course? Okay, even though it's a graphics course, okay, but you are not going to learn any graphic software packages such as this one. Okay, 3D Max, Photoshop, okay, Maya Studio. All these are modeling software. So we are not going to learn it. Okay, so you are software engineer. Okay, this is low level graphic programming course. So you are going to build this software in futures for the artists to use. Okay, and I also didn't teach you all this artistic skill. Art skill, how good your drawing is not important. You have to create the graphic, but how good is the graphic, that's not important. Okay, your accent. Okay, so your miss won't laugh at you. The art that you create, the graphic that you create. I just need to see, do you able to create, not how good the graphic is. Okay. So I won't laugh one. Normally you are the one that you laugh yourself. You create the graphic and you see miss, you see so ugly, and then you laugh, or you laugh your friend one. Okay. So art skill I won't assess and also this is not a game course. Okay, it's a graphic course, but it's not a game course. Okay, so no need to do any game design. Even some of you want to explore, you are fun. You are very passionate, you love the subjects, you want to do some game elements inside there, is up to you, but it's not, you are not learning that. Okay, it's optional. Let's see the assessment. Okay, see the assessment. Coursework, how many percent? 70. Okay, so this is very coursework heavy subject. And your miss recently get a high failure rate after MCO. You guys exam drop. And please study and don't repeat my course. I warn you at the first day of the semester. Okay, very coursework heavy subjects, 70%. So your coursework is break down to three components. Okay, first is your assignment. Okay, assignments have the most marks there. You can see 60%. Okay, this is group assignment. Okay, group assignments. So I will go through with you guys the question in detail during your practical class later. Group assignment, so don't worry, you have your friend to work with you. Okay, in programming teamwork is important. There is no hero. Okay, work in group. Practical assessment, this one is your practical exercise. Every week after I finish your practical demo, okay, you have homework to do. Okay, practical homework that you will go back to do, and then you show me the next week. Okay, so you have to get your hand dirty with all the code, very hang-on subject. Okay, practical assessment 20%, and because still got exam, exam 30%, final exam. Okay, last time 30% exam, we only do 1 hour paper, but now they're standardized. Even though the weightage is 30% for your exam, but you still sit for 2 hours paper. 100 marks, 4 questions, so each question will be 25 marks. 30% final exam. Okay, because got final exam, so I give you midterm test. Got midterm test. Okay, midterm test 20%. So now your miss put there, ideally we can do on week 8. Week 8. Week 8, half of the semester. When we finish chapter 5. Okay, got 10 chapters. So if we finish half of the syllabus, chapter 5, that means you can study for your midterm test already. Okay, your midterm test will cover chapter 1 to chapter 5. Okay, half of the syllabus. Okay. So in this course, okay, we will use the graphic libraries or the graphic API called OpenGL. Okay, OpenGL you no need to install separately. Okay, you just install Microsoft Visual Studio. Okay, we use Microsoft Visual Studio. Okay, the language is similar to C++. We do C++. You have background with C++. Right. All good. C++? Forget already. Forget already. Never mind, you will recap back. Pretty fast. Your miss now teach both language in one semester to switch. I also teach the OP in Java. Okay, so when you install Visual Studio, so go back home, make sure your home machine got Visual Studio. If don't have, then you install now. Okay, go and install the latest version. 2023, latest one. Because this year is 2023. Okay, lab 1 is still using 2022. Okay, doesn't matter whichever version also can use. Okay, but make sure your teammates, the one that do assignment with you together, same version, same version. Your friend, you choose your friend. Okay, that going to do your assignment. Make sure both of you use the same versions of Visual Studio. Okay, don't one use 2019, another one use 2022, another one use 2023. Later when you do integration, you cry there. Okay, make sure same version, so easier for you to do integrations of your source code later. Okay, so when you install Visual Studio, okay, there is a Windows SDK. Okay, SDK means software development kits. Software development kits. So if you didn't uncheck that one, okay, it's installed together. When you install Visual Studio, then the OpenGL is inside. Okay, OpenGL is inside. And why we choose OpenGL? Because it's device independence. So you can just use in any device. Your tablet, your PC, your phone also can use OpenGL and any platform. Okay, it can be used in Linux, Windows, Macs, any OS. Okay, and it's free, open source, free. Okay, so it's independent. So you can use, and it's also when you install Visual Studio, it's already there. Okay, OpenGL. This one I will guide you later lah when we do practical. Okay, practical. So we start chapter 1. Okay, chapter 1 is introduction. Okay, to 3D graphics. Okay, just very brief introduction, so very short. Okay, that we only learn 2 things here in chapter 1. Okay, so we look at some examples of applications of computer graphics. So if you heard short form, someone says CG. CG is referred to computer graphics. Okay, look at some application and a brief history how CG is actually evolved. Okay, from the past to now. Okay. So examples of the computer graphics is widely used in design. Okay, design. Okay, people used to design different types of products. Okay, computer aided design. Okay, short form you will heard this as CAD. Okay, for those engineering student, okay, or the art student, they're going to use this, okay, to design their products. Okay. Okay, analysis. engineering analysis. Okay, graphics. Love. Everyone love to see graphics. Okay, just display your graphics on the computer. Okay, you don't like to see this? You love to see this or not? Okay? Oh. Okay. I don't want to see this. Then see this. Nice. So thanks to graphics. And really thanks to graphics. This is molecule. Okay? So you want to see all the text just now? This one you can imagine. Last time I tell you what is DNA, what is molecule? Cannot imagine, don't know how is it. Okay, show. Okay, with graphic then you can show. Easier to understand rather than pure imagination. You know how it's look. Some more got simulation, got movements, got animations. Later you also going to do animation. Move one. Okay, not static. So this subject will bit different from all your previous subjects. Okay, because we deal with graphics. Okay, software engineering student, you don't have background on graphic at all. Okay, not like interactive software technology. ST student that have graphic background. So for you guys, it is consider new things. Okay, simulations. Okay, another examples of CG application. Okay, when we do CG, then it will be more interesting, more immersive, more fun. Okay, so data visualization. So now I want to talk about big data. Okay, we have a lot of data. Okay, so how you going to represent it using graphics? Okay, the common one, traditional way, you use all this bar, pie chart. Okay, so now we use map. Okay, so this one is the aircraft system. You want to see where is the aircraft in the map. Okay, so everyone actually using graphic applications, and just like your phone, if you're using Waze, okay, location service, okay, or Google Map, you're actually using the computer graphic applications. Okay, that with the graphics. So graphic represent 1,000 words. You can represent a lot of data in just one pictures there. Okay. And medicines. So last time people, you go to do X-ray, still want to print out the hard copy. Now no need lah. Everything can see from the computer. Can just see your X-rays result from the PC. Okay, that is for medicine. Okay, and it's very easier to see in different angle, 360. Turn this, 360. X, Y, Z. Later you also going to turn here, turn there, 360. Your model. Okay, your graphics. Okay, architecture, design. Okay, so before you actually build the building, up. This one is floor plan. Okay, the left side here is the floor plan. Okay, this one your building. Okay, you can create the model first. Okay, using your PC. Okay, and then only you see whether it's feasible to build this building out. Okay, architecture. Okay, product design. Okay, simple one. Okay, animations. Cannot run away. Graphic cannot run away with animation. Games. And movies. Special effect. Okay, so with the help of CG, so you can create all these animation movies. All these people use PC to create one. Okay, like all movies, Lion King. Okay, special effects. Special effects is using CG to create. Okay, your computer to create. Okay, can do anything lah. This one is history last time. The Green Man. You really go and make up the map. Now no need lah. You just use PC to create. Special effect like the building explosions. Okay, you go and bomb the KLCC, but the KLCC is still there. You can see. But movie you can see is bomb. All this using PC. Okay, computer graphic to create. See how the improvements of CG. So now the most recent ones are what movies we have. Transformer. Okay, a lot of CG inside. Very good. Go and check the latest CG techniques. Okay, but for your level cannot create until like this yet. Okay, so we will create the basic one. Okay, basic one. Okay, because we already learned the bounding method. Okay, so in Tally, your miss also show you the history. I can see the history. History of how the improvements of CG, the use of CG in this special effects or the graphics. Okay, with computer, the graphic quality really improved a lot. Okay, even though last time OS before 1995, there's no window. When your miss first touch PC, no windows. So I need to, there's no right click copy and right click place. Okay, it's command prompt. I want to copy one file to another location. I need to type MC copy from A ... to C ... command prompt. Okay, that is last time, no graphics. Okay, that's why graphic is really help. Okay, a lot. Even though last time there is no digital camera, but you take phone, take your pictures using phone. Don't have. Last time the camera, the big camera, you need to have the film. Okay, you take pictures, you have to wash out, then only you can see your pictures. I cannot just take and then directly can see already. No. Okay. So games, any games lah. Okay, this one is old school game lah. Don't put. Okay, so now we go to the history of the graphics. Okay, when we start to have graphics, there's no color, only 2-bit colors, which is black and white. Okay, black and white only. Last time the first game that your miss play in the phone, black and white only. This is Pong. The game name is called Pong. Okay, last time it's called the snake game. Okay, also black and white only. Then we start to have colors. A little bit of color, but primary color 4-bit. Okay, 4-bit colors. Okay, RGB, all the primary color. Red, green, blue. Okay, plus for black and white. Improve. Okay, improve. Okay, 32 bits, and then improve to become true color, full HD. Okay, this is how evolve lah of graphics. Okay, last time your miss do PS2 game, the first PS2 game in Malaysia. Okay, I developed. It's only 4-bit colors only. 4-bit color, long time ago. Yeah. So we start CG actually start from 1963. Okay, history. Okay, start from these guys. Okay, father of graphics, Ivan Sutherland. Okay, just to create, to draw. Okay, to create the graphic on the computer, you need to have the big machine there. Okay, you can see from the picture there, the big machine. Okay, just to create this black and white graphics. Yeah. Okay, you need to have the whole studio like this. Big TV. Okay. But now the device, everything getting lighter, smaller. Okay, even your LCD screen now is flat like this. Last time your is the monitor big one. Okay, like the TV also last time is like this. Now it's all flat. Okay, and your phone is getting smaller, smaller and smaller. Okay, last time the phone is the big one. So Miss first use lah. Okay, so 1969 then we start to have this vector display. Okay, vector display, even though it's black and white, you can see 3D. You have the deafness go inside. Okay, that's the vector. Okay, then we have a big improvements. Okay, one big milestones in 1970. Okay, when we start to jump to color. Okay, just now black and white. Now you have colors already, RGB, red, green, blue. Then we have this raster graphics. Okay, raster graphics, then we can add in lights. You see the sphere here, got lights here. This is brighter, darker. Okay, then we have surfaces, curve, round. Okay, textures. So these things you also will be studying later. These are the things that you will study later. Okay, texture, curve, lighting. Okay, hidden surface. So when you have 3D, then the back surface should be hidden. It's not shown. You only see the front face. Only see the front, back cannot see. Okay, that is called Z buffer, hidden surface. Okay, anti-aliasing. Where anti-aliasing? Okay, aliasing, you can see this dot pixel rate, pixel jiggle, this one. This is called aliasing. Okay, when you zoom your picture big, very big, and then you can see all the pixel like this. This is called aliasing. Okay, pixel up. Okay, have to solve this one, no? Solve this one. This is called anti. We have the solution to solve this anti-aliasing problem, which is happen when you scale your pictures. Okay. This one, the Pong Games, is on 1972. Okay, in order to play this game, you have to go to a shopping mall and then see this big machine there, and then put in your coin, and only you can play. So you are very lucky now. You want to play game, your phone, you can just play anyway. And everyone have PC. Okay, last time cannot afford PC because the PC is a whole studio like just now. It's a big one and very expensive. So everyone want to play game, then go to shopping complex and then go and play all these arcade machine game. And then the game is only like this. So simple. Black and white. This is your Miss Era 1980. Big improvement here when we start to have this enumeration. Okay, where you will know where is the ray mean the lights, the light come from. Okay, ray classing, ray tracing. Okay, when you know this one shading, that you can have this kind of effect to know the directions of the lights. Okay, you can have photorealism or photorealistic graphic. Okay, at this era, 1980, when have this graphics, CG in illuminations, then only start to have digital camera. Digital camera that you can take pictures and then you can see your stuff. Okay, before this, no digital camera. Okay, only the film camera you have to wash out, the hard copy. Okay. So when people have realistic already like this, not very realistic photo, then people will come to non-photorealistic. Oh, another 10 years, then people go to non-photorealistic rendering. Okay, or we call as cartoonist stuff, or shell shaded. So you see this model, so you put an outline. Okay, put an outline, okay, to the model. Okay, then you can have a non-photorealistic effect. Okay, support volume rendering 3D. 3D. Okay, 3D already. Okay, this perspective view, 3D. Okay, 90. Okay, so stop already here. Okay, got 2000. So 2000, where we go? No, don't have done already. So now where we go? So now everyone talk about CG. Now talk about AR and VR. Okay, augmented reality and virtual reality. Okay, bring the graphic out. Bring your graphic out, and then bring you inside the graphic. Okay, Oculus Touch. Okay, but you are not learning that one. Okay, so this is just like you to see some improvement, the big milestones of computer graphics. Okay, with this one we done chapter 1. Chapter 1 done. Any question? Chapter 1 not much thing just the example application and the history. Okay, today by right need to finish chapter 2 also. Any questions? If no, then we continue chapter 2. This one last semester I cannot finish lecture. Last week 14 only do chapter 9 and 10. Then normally after week 11 you guys will absent lecture Yeah lah, because it means I have 4 assignments. This week I have 5 assignments. Then only I cover chapter 8, 9, 10 6, 7, 8, 9, 10. They all cannot answer the question. If you don't come lecture, you need to study for your exam, study for your final exam. So many field. I understand you can ask during tutorial class. Okay, normally chapter 1 will have less question. Only 1 question or 2 question. Just ask on the application. Okay, tell the benefits. So done chapter 1, you can start do your tutorial 1. Tutorial 1. Then we can discuss during your tutorial class. Okay, so now go to chapter 2. Okay, chapter 2 only start graphic pipelines. Go inside the theory part. This is theory part, graphic pipeline. Okay, chapter 3 only the code. Start the code. Okay, so what we will do in chapter 2, graphic pipelines. Okay, the whole chapter 2 is only study these graphic pipelines. Okay, what is graphic pipelines? Okay, how your real world, your graphic pictures here from real world. Okay, to go through your graphic card. Okay, your graphic pipeline is in your graphic card. Okay, to something that you can see on your computer screen. Okay, on your screen, not computer, any devices screen that you can see the graphics. Okay, must go through the graphic pipelines. Okay, and graphic pipeline we got split to 2. Okay, one is the fixed function pipeline. Okay, fixed one means it's your graphic card. A fixed one, you cannot do anything. Okay, the graphic card will do the job. Okay, that's fixed. Okay, then your another one is the programmable. This is your job, programmer, the one that you can program. Okay, the part of the graphic that you can program. That is what we going to do lah. Okay, to improve our graphics. And then we will start with graphic API. What is graphic API? application programming interface. API is like graphic library, like your OpenGL. Okay, is to communicate. Okay, communications between your program that you write and your hardware. Okay, your graphic card. So application programming interface API. So it consists of what is graphic libraries. Okay, a set of functions. Okay, a set of graphic functions. Okay, it will be interact between your application program that you write and your graphic system. Graphic system means your hardware. Okay, your graphic card. So the common one, we have OpenGL and DirectX. Okay, so for you guys only learn OpenGL. So for ST student, they will learn DirectX during their diploma, year 2, and then when they come to bachelor year 2, they will learn OpenGL. They learn both. Okay, so DirectX is license paid. Microsoft product means license. Okay, OpenGL is open source. Okay, there are graphic libraries, or we call it as API. It consists of all the functions that you can use to create your graphic. So it's a low-level language. Okay, OpenGL is also not so low lah. Just like your C++ is also called high-level languages. It means you can understand. Low level is your assembly. Assembly language is a low level. Okay, you can see here interface. Okay, you have your program here. This is your program that you're going to write later, your OpenGL program. Okay, your OpenGL is in the middle. Okay, connect your program with your hardware. Your hardware is your device lah. Okay, your keyboard, your mouse, to get the input, and then your output to your LCD, your screen. Okay. Oh, just now got student ask what you learn GLU or GLU or GLUT. Okay, we will learn GL and GLU. Okay, GL and GLU. GLUT is for window management, keyboard, mouse, and menu for input. Okay, so for the input, I will just teach you the normal window input. Okay, if you want to create menu, you want to use mouse, you want to learn extra, you can use GLUT in your assignment, but it's optional. Okay, window input is enough. So your miss won't teach you GLUT. I will only teach you GL. Okay, and GLU. These two we will learn in the class. Okay, so GL is to draw the basic shape. Okay, like triangle. Okay, like your quad, your polygon. Okay, GL. So GLU is a bit higher level from GL. Okay, it will have more complex objects. Okay, like sphere, cylinder. Okay, it's in the GLU library. Okay, we will learn this. Okay, don't worry, eventually in your practical, we learn together. Okay, so all this library is for you to communicate your program with your hardware. Okay, what is 3D graphics? See this graphics. This is 3D or 2D? 2D, 3D? Okay, your computer screen is 2D or 3D? Okay, why you say this is 3D? Shadow? Where got shadow? Got shadow what? What made you say that this is 3D graphics? Even though you know your screen is 2D, your screen is flat. But you know this is 3D graphics. Why? The answer actually is in the next slide. What made you say that this is 3D? Okay, what is D there? What is the meaning of the D? Dimension. Okay, 3 dimension. Okay, which 3 dimensions? Okay, your width, your height, x, y, and your depth, z. Okay, when you see 3D mean you have the depthness. Okay, so 3D graphic can show on a 2D computer screen when you have the illusions of depthness, the third dimension, the z-axis. Okay, so how are you going to show the z-axis? Okay, so 3D refer to the objects that have 3 dimensions, your width, your height, and your depth. Okay, your width means your x. Okay, your height is your y, and your depth is your z. Okay, so if you see a paper, okay, example, okay, paper, this one you should know is 2D because there is no depthness. Okay, no perceptions on the depth at all. Okay, so a soda can or the graphic just now, this one is round, so you have the width and height, you also have the depth. Okay, so the graphic pipelines, okay, is to determine how you can visualize a 3D world. Like this 3D world, you take pictures, at the end I can see you in the PC is 2D. You are 3D. You take picture yourself and you see your pictures is 2D. You yourself is 3D. So when we do projections from the 3D real world to your 2D computer screens, it reduce 1 dimension. Okay, reduce 1 dimension. Okay, so the illusions of depthness or the third dimensions can be shown by using the perspective view. Okay, perspective view. So your 3D graphics are actually is a 2D images on the flat computer screen that just provide the illusions of depthness or the third dimension, which is the z-axis, by using the perspective view. Okay, so even though the model, okay, the model is 3D, you already draw your graphic in 3D. Okay, but if you only view from the front view, top view, it's still flat. You can still see 2D. You see, even though it's a 3D object, but you see it's 2D. So you want to see it look like 3D, you have to use perspective view. Okay, you see that 2D plus perspective, you get 3D. Yeah. So we have another view we call as isometric view. You know what is isometric? Isometric is actually, you heard people say 2.5D. 2.5D is isometric view. Okay, it's actually is a 2D. Okay, isometric is a 2D. So they just take the camera up and then look down 45 degrees. Then you get isometric. Okay, you have some kind of 3D field. Okay, even though this one is all the graphic is actually 2D. That is isometric. Okay, you can see example here. Okay, this is isometric. You guys have to let your miss know if already 6. Guys, I will just stop. Can just stop. Talk this, then can stop. Pipelines, we continue next week. Okay, so 3D graphics. Okay, everything that you show on your screen, okay, will through the projections. Okay, must have your camera. You can see that camera. Okay, this is your 3D world. Okay, you take pictures, at the end you will project onto the projection plan. Okay, projection plan, or you can project on your screen. Okay, then it becomes 2D. Okay, so projection will be your chapter 5. Okay, we will learn in detail projections on chapter 5. Okay, the 2 types of projection, orthographics and perspective. Okay. So next will be the graphic pipelines. But due to time constraint, your miss. This one, your miss will continue next week. The graphic pipelines. Yeah, because I have to explain one by one. Okay, very important. Okay, so that's all for today. Any question? Okay, we will continue lecture next week. So I see you in your practical.